Hey guys, so hopefully this recording will make it to YouTube because it's my third attempt. So enough of that self-pity. So this is going to be my video series tracking or logging or recording my progress on my final project for my master's in computer science. And the reason I'm recording it is it's something new for me, new experience, and also kind of motivates me to get on with the project for the sake of the videos. The videos force me to record what I've done, which will hopefully turn out to be useful for when I write my dissertation or while writing the dissertation as I go along. And who knows, maybe people actually watch these videos, give me some feedback, leave some comments, and yeah, maybe I can do even better. So without any further delays, let's go into it. So yeah, got a GitHub page. You can read it there. I'll give you some background and motivation. So the first one, I won't go into much detail, but let's say there's some history between Polyphony and myself that didn't pan out the way I wanted. And I was planning on trying to find something to do either with Gran Turismo, PlayStation, or AI in general. And Sony and Polyphony released, published a paper earlier this year. I guess they were working on it, late last year. This year being 2022, and it kind of was on the lines of one of the ideas I had, and the fact that they beat me through it just makes me feel like, ooh, wouldn't it be cool if I can do something around what they did and hopefully get enough success to divert some network traffic in order that they themselves notice me, and then it's like, haha, got you. I don't know if it will work that way. But anyway, it's fun. It motivates me. Second one is I've always loved PlayStation. I've loved cars. You can see behind me there's Super logo, racetracks, PlayStation. On this side I got like racing manga and Knight Rider kit car. I've always been into cars, racing games, and yeah, actually I studied motorsport engineering, but deciding to get into engineering is kind of very late in my education path. I always wanted to make video games, and I only decided to study physics, with the idea that to model realistic car behavior in video games, you have to know physics pretty well. Now it's like feels very obvious, but you can imagine as a 12-year-old that stuff was feeling deep and reflective. But I also fell in love, or developed more love for the automotive, and yeah, I thought, why not? Let's do engineering. Maybe I get into the automotive industry and maybe work for Toyota, and if not, hey, I have a fallback into video games. So that's what I thought. But the computing world evolved way beyond where I stopped. And yeah, and then I got to work for Toyota Group. I joined, and so yay, where I've been for over 10 years, maybe like 11, 12. And yeah, so I fulfilled curiosity and desire in one world, the automotive, but left the computing part, the game dev, a bit vacant. So that's one of the reasons I did the Harvard CS50. I enrolled into this master's in computer science, and why I'm doing this, to scratch that itch. Yeah, also, during this master's, I fell in love with AI. And by AI, I don't mean like rule-based problem solving, where you could argue there's a mathematical optimum, like tic-tac-toe, or, min-max or max-min, I can't remember what's called, optimization for games like Connect 4, and that sort of thing. But rather, I love AI that has to do with neural networks. And if you take supervised learning like cat, dogs, image recognition, right? To me, that's pretty much how we teach humans, right? Kids have books with pictures of animals, and You know, their first word might be dog, and you say no, cat. And you know, it's a black box. How some kids get it immediately, some kids may take longer, and we don't know what patterns their brain is associating to the word. It's only after several cycles, right, of supervised learning that they start to mostly get good answers. And think about language, right? They're processing and randomly capturing patterns in how we communicate the first language, your native language. And I think neural networks are pretty much like that, right? Like this branch of AI. And reinforcement learning is another aspect, you know, unsupervised training, which I feel is similar to, you know, driving a race car. You practice by yourself on the track. Maybe the only difference is to some extent, you know, perhaps what are the right reward values. I don't know. Do you really do? Sometimes you think you're getting better and then you observe your lap time, you're getting worse. I don't know. But I see a lot of similarities with humans and this branch of AI. In fact, I pretty much think that neural networks is a perfect way of modeling the way humans think. And beyond my superficial claim, Professor Joshua Bach, I hope that's how you pronounce it, he gives some amazing videos, lectures, conference presentations, and really interesting publications in cognitive consciousness, psychology, the universe, everything, and how he believes AI is the best, and computers and AIs are the best way of modeling the universe and human behavior. So amazing stuff. Supports like what's maybe intuitively my gut feeling, but you know, I'm a nobody. So it was nice to come across his work. Some legal comments, you know, I'm going to be using references and using Gran Turismo itself. I own the copies. I have them somewhere here, the EU, UK, and US releases. I think here, if someone's going to zoom in, I only have the EU and Japanese release. I probably have the other ones in either the other room or in the attic. Anyway, I own the games. I bought them when they came out. I probably scratched some of them, so I have also repurchased some of them as used games. I have some of my original PlayStations. I have some spares. The game, I have multiple regions because I lived many places, and I'm a geek. I'm an otaku, so yeah. Anyway, so I'm doing this for fun, education, and research. So I believe they fall under what's permissible for fair use usage, and I'm not relying on stolen information, and I'm not trying to generate any revenue from this. So I hope no one will beat me up, figuratively speaking. And as much as possible, I'll eliminate the soundtracks from my recordings, just again to do my best to not upset any copyright holders. So then let's jump into the plan. So the plan is pretty simple. I am going to make a series of videos, hopefully, on my goal to develop a racing agent for Gran Turismo for the original PlayStation. This is going to be like a logbook of probably what you should not do, because I'm going to come up with stupid hypotheses and even dumber ways of trying to prove the hypothesis, which most likely will invalidate the hypothesis, I expect, since I'm a noob. Some of the basic things we have to do is develop a way of capturing the screen. I mean the display output of the PlayStation. In this case, I'm going to mainly work with emulators. So, and my emulator of choice is Redux. We have to make sure it's fast. We're probably going to have to do some post-processing on that capture before feeding it to our AI or neural network or whatever we call this next black box. And we have to encode some parameters of what we're seeing and what is happening in the game. So my guesses are at this moment, and they're purely guess, I need to do some research to come up with some more, let's say, academic or theory or prior research based guidance. But I guess we're going to have to encode some things like distance from the limits of the track, distance from the car ahead or any other object. But we also might have to encode other things, which either we might try to encode from game memory, audio, or I don't know, some other methods such as, you know, vehicle speed, engine speed. And the reason I say or is I will be using emulators and they do give us some shortcuts, but as much as possible I would like to stick to methodologies which can be easier to replicate with real hardware. And also, I mean, it's not too bad. There's also the issue of, you know, what to encode. I also want to remain fair, like take when you're driving a car racing, you're going to probably remember and visualize with high focus the apex of the corner, the edge, the curbs, where your opponent is, but you're not going to visualize and memorize, you know, where were the spectators in the grandstand and if they're in the same place the next lap round, because it's irrelevant, it's noisy. And similarly, we will have to encode or try to encode everything that's on the screen. Some things like vehicle speed, engine speed, we have them on the dash in a real car, on the instrument cluster, but I suppose you're not continuously looking at them, or at least let's say I suppose most good drivers will not be looking at them with the same attention. They're paying attention at the apex of the corner they're attacking or trying to mentally visualize the corner after that. Instead, you're relying on a, I guess, background process in your brain of converting the engine sound vibrations to some sense of speed and engine RPM. So yeah, I mean, in some cases I might take shortcuts and actually just try to read the RAM value or OCR, the instrument cluster from the heads-up display on the game. I think it's just to avoid the hassle of, you know, trying to pretend the game is sensing the speed from the sound, or the agent is sensing the speed from the sound. For screen captures, I have a number of methods. Some I've tried already in the previous recording, some I haven't. So the first 4 standard library concepts is the image grab method, the pyautogui, MSS, and another one, this is the one I haven't tried, D3D shot, which I came across from some work of someone who did something similar, as in trying to make some machine learning library for video games. And he seems to have developed this library for really fast screenshots. I don't know if it will work because I am using Conda to manage my packages and environment, and this is too niche and recent that no one's made a Conda package. It's also Windows only. Could be some of the ones above are also Windows only, but I haven't checked. Other ideas which feel like too much of a shortcut to me would be to jump into the VRAM from the emulator, something I definitely won't be able to do on real hardware. And it's not ideal either because the Gran Turismo is running in dual buffer, and therefore I would either need to develop a method of picking different sections of VRAM according to which of the 2 buffers being displayed, or having the frame rate, which feels like it would undo what I'm trying to do by finding a fast capture method, if that makes sense. The other possibility would be to modify or get the devs of the emulator to add a feature for me to directly feed the video stream to my Python environment. And so if any of the maintainers of the emulators watch this, yeah, don't forget me. Yeah, later we'll do some screen edge detection. Maybe we'll flick back to this later on. Good. So, yeah, here's my notebook. I'm using notebooks because it makes running blobs of code easier. Here's Gran Turismo already loaded. And so, using the screen capture method, I want to define a region of the screen to capture. And my thoughts are to capture, obviously, this whole display for now. And in order to facilitate, in case I move this emulator window or something of the sort, like let's say I move the diagonal, its pixel position has changed, I have this mini helper function which gives me 3 seconds to position the mouse there, 3 seconds to position the mouse here. Yeah, we don't need to care about the pixel perfection for now. We got those positions, ignore this. And here we go. This is the first routine for capturing the screen using the PIL image grab library. So there it's running. If I switch on my controller, which is, what is it? It's Trust controller. Good. So let's see. So according to this, we're capturing at 15, 12 frames per second. It's not ideal, and you can definitely notice, right? The continuous flashing at a very high speed, high flicker rate, whereas here it's a bit aliased. You sometimes see it flicker, sometimes it happens to remain white, sometimes it happens to remain red. So it's pretty crappy, I think, but yeah. It's playable. You know, it reminds me of my Pentium 1 days when I was wishing for more RAM or a CPU upgrade or something of the sort, you know. Yeah, so definitely not cool. I mean, of course, what we could do is try to reduce the screen size. Let's do that. Let's see, because I don't know what sort of resolution this is. So it was 706. Yeah, so it's not too far off the mark from what PlayStation natively would be. But yeah, let's just see. Let's just see, does this make a difference? So we grab the screen again from there to there. And then run this. How do we do? That doesn't... Feels like it almost got worse, so I don't know. So there we have it. This is method 1. That was the PIL. You know, 12 to 15 frames per second. Then pyautogui. How's that doing? Pretty much the same. Then MSS, which promises or seems to the internet suggests it should be the best. Subjectively, I don't know if it's science, it does seem to flash a little bit more consistently, so I don't know. And yeah, I mean, it's never dropped to 12 frames per second. It's like now 15 to 20, 14 to 20. Let's see, just for completeness sake, just in case it's a background process on my computer. Does this earlier one go back to... Okay, definitely this hits 12s, right? 11s. So at least MSS is faster. About MSS, this is one of the battles I had getting to install. So on the list, as I said, I'm using Conda to manage my Python libraries or packages. So I installed MSS and thought that was it, and I kept getting errors with MSS library not being there. After some searching, it turns out I need Python MSS. So I don't know if I really needed MSS, but you definitely need Python MSS to import MSS. Now, there is one more method I came across, which is this one. Seems pretty good. It says it's extremely fast and robust screen capture. Now the only issue is I didn't find the Conda library for it, and I have never. Well, I tried once a pip install in a Conda environment. Let's see if it works. So far so good. Okay, it needs pillow and it needs con types. There we go. Errors. So what are the errors? I already have pillow. So pillow. Yes, it seems it tried to build from source, I guess. Okay. Maker web pillow. It's a bummer. Maybe I have to figure out how to make Conda libraries. Let's see. Okay, this package will be updated. Okay. Let's put on the nope. Okay, wait. So it's trying to install Pillow 9.1. And where was it? What version of Pillow do we actually have? This might take a while. So okay, I have 9.1. So I don't know. No clue what's the issue here. So what does the website say? Dependencies. Okay, Python great rate good at 3.6 should be fine. I have 3.9. Is there some? Needs pillow. Okay, needs con types. Okay. Just in case. Let's check. So, I mean, I've never had any luck with pip when using Conda, so I have to figure out a way of adding this later on. Well, most definitely. So, okay, that's interesting. Will this make no? Stop. Install the 3D shot. So this wants to install Pillow 7. Well, I don't know why it even tries because there must be a manual way. Okay, suppose source build. Let's see what would normally be. Yeah. Let's do it another time. Anyway. So yeah, sucks a bit. Where are we at with recording times? 24 minutes. So yeah, clearly it seems MSS is the best way of doing things. So wait, what was this? This was, yeah, MSS. Is this the same thing? Oh yeah, I guess I had copied and pasted the code to be ready. So since we have some time, yeah, let's go back to what else is needing to do. So one thing I will say, which I forgot to mention, is about encoding the environment. This is going to require a lot of thoughts, right, on what do we want to encode from the environment. So if we go to the emulator and maybe restart the race. So my ideas, my thoughts, is to develop the agent that runs the game, first of all, in the first person view. Back in the day, this was known as the RRR view from Ridge Racer, but so one thing about this view, right? You see as I tilt and slide and do this S, and the camera tilts. So the car roll is embedded into the perspective. That's one. And as you steer left and right, so as the car is man, what do you call it? Yawn? Yawn, you're right. Roll, pitch, yawn. So as it yawns, it's actually steering, and where you can see in the screen view changes. It's like you're tilting the camera. Whereas if I momentarily switch to the external view, you can see we lose the roll and we lose a bit of the perspective. And there's some inertia for the niceness, but you know, we can see the side of the car. So the camera is not perfectly following the car, if that makes sense, the rear of the camera. There's some rubber, bendy elasticity, and you know, and here we quickly slide the camera the opposite way. So therefore, I think the first perspective encoding is better. The next thing we'll have to think about is track limits and other spatial parameters, how to encode that. So for example, some ideas I had, maybe I need to pause this that we can see the screen or the rear of the car. Let me catch up to one of the cars to maybe make my point. But yeah, I'm almost sure we'll need track limits to be able to know how close the car is driving to the inside of a corner and outside of a corner, and how to know it's not off the racing area. So let's take here. So I think I will want to detect the distance to the rear of the car. So yeah, if we have the car, probably we need to detect to the rear, because that's the real distance and track distance. I think if we detect, you know, from a perspective and simply measure the vertex, it might be inaccurate. I don't know. It might not work. So I don't think it's too important to know where the front cars are pointing. So even though obviously this is looks like it's going a straight line and this one's going slightly right, they're roughly in, let's say, a range of angles. So I think it's not going to be super important to be able to capture in which direction they are going. And but I think we need to know how far we are from them in race distance, and I think especially when we're close to the car, how far we are to the left and the right. And probably the left and the right will be able to, I don't know, make some experiments to define. Like obviously if I drive straight here with it in front of me, I'm going to hit it. That's the famous Corvette. So let's try to hit the GTO. Why not? So yeah, maybe I'm slowing down to let the GTO pass me. But anyway, we'll be able to find by trial and error. If say the car is here till this part, maybe it's not a collision, but 5 pixels to the left and it's a collision. I don't know. I will create some boundary lines. But of course, the other thing we have to do is detect the edges, and this is where the what I thought would leave for another video is not left for another video, is what sort of processing we can do. And spoiler alert, I think I am on the right path, but unsuccessful so far. So most of what I've read and most of what people are doing on modern games for this sort of thing are mostly utilizing openCV's Canny Edge Detection, which is, the Canny-based algorithms for detecting the edges, which is basically detecting where there's a massive, I guess, luminance or brightness in this grayscale representation gradient change. So, if there's a gradual shades of gray, man, shades of gray has become such a uncomfortable phrase, but if it's a gradual change, you have a low gradient, and if you have a sharp color change, it's a high gradient. And basically, by setting some parameters of, I don't know, gradient ranges to define edges, it will then generate this black and white edge detection. So this is all from the official documentation, both visuals. This is the explanation in the docs, and this is an example from the documents. So we go to my main code, and I actually implemented Canny Edge. And so when I was doing this, one of my assumptions was that the PlayStation would be easy to perform edge detection. Why? So if you think about most of the similar tenets at old retro gaming, like the Atari stuff, you have super distinct bright colors, right, because of the reduced color palette, and also the high pixelations, like you think Pong, the classic Pong, right? It's very hard to not know where is the pedal and where is the exact pixel collision of the ball and the pedal. And modern games, right, have super high res game screens, so I assume that they're very hard, let's say, what's the word? Computationally exhausting. And I think, or I assumed, or I still partially assume, that the PlayStation game should represent a medium challenge in all aspects, right? Because we have clear sense of 3D, but it's small resolution, so hopefully not high computational effort, and yeah, we got more colors. Now, since we believe, let's put it this way, we believe the MSS to be the best method at the moment, so what can we do? What can we do? How to do this? So I guess I should have called these something like, I don't know, MSS. And okay. And just so I don't forget, because I'm bad, I'm gonna quickly edit these. So let's call this UI. And let's call this no. Good. Yeah, I probably did all of this for nothing, but because this will be a main loop, right? Yeah. We'll be stuck in there. Okay, we did this minor change for nothing, but hey, whatever. So MSS is best. So let's copy this cell, create a new cell. No, we can refactor code later. So now, yeah, one thing to watch out for is pyautogui and the PIL method capture in a BGR method. So I have to pass the CV2 filter to convert BGR to RGB in order to display it. what's cool about MSS is the capture is native RGB. So to display it, I did not need to do anything to that image. But I wonder if it will cause issues with the Canny. Let's see. So it shouldn't, but let's see. So we don't need that. And what we need is my Canny helper function. So let's see, yeah. So BGR to gray. Is there an RGB to gray? Let's see. Is there an RGB to gray? CV2, the color. RGB. Yeah, I guess RGB. Color. BGR. Only one way to find out. Let's see. Let's see. You have complaints about that? If not, I guess it exists. So we got process image method. We jump down to here, and so we don't make a. Is it Canny with a double N? Man, I'm so bad at these moments of, yeah, spelling. So let's see. We took the image, then what did you do? Oops. We process the image, so pass it print screen and result. So technically we could put the result on itself, but yeah, let's see. And let's display the result instead. So let's go. Let's see. Hey. Okay, process image is not defined. We probably need to run this block once, so Python knows what that function is. Okay, so I'm not dismissing Canny Edge because there are some parameters we have to optimize, but as you can tell, we cannot reliably see the edge. Now, one thing I need to make sure is that this is not caused by the way we are converting colors. So let's do this. Let's temporarily remove the edge. I just want to be sure that the grayscale effect is working. So this should give us the display in grayscale. Okay, the grayscale seems okay. Yeah. Pretty amazing that we still got a decent frame rate, but yeah, the Canny Edge doesn't work. That's good, as I would like it to. So I don't know, you can play with these parameters, and probably will make an automated way of testing the spread of thresholds, but I'll try to describe what I think is the main issue and why I think that doing it on a PlayStation is going to be less fun than I thought. So let's see. Yeah, to be honest, it's a bit different from what I got the last time, but let's see. So, I mean, we got a couple of issues here, right? Besides that, we don't have a continuous line. Yeah, we just totally don't have the edge of the track, but I think what's more irritating or inconvenient is we can detect this edge of the shadow. So the gray is different enough to detect it, but then the other issue is, and here, if we take here this banking, right? The wall is a similar grade to the track in the shadow. So we pick the edge of the shadow, but we cannot pick the edge of the track. And so I don't know, this is going to be issue one. And the second issue is, even if we look at the simple starting line of the track. So you can see the low, oh, that's a nice pause. So the low poly nature of the PlayStation means even right here, this zinc, this, I don't know, this aliased line is detected with breaks, and the fence further up lacks the resolution to even capture that white part. And you'll see in game, yep, as we get closer, it pops in, right? The characteristics of the PlayStation. So I think these are going to be unique challenges. I had in mind, and maybe we can try this now, is to check if we use another emulator that can do higher res, would we run into the same problem, right? Anyway, this video is already 40 minutes long, so I think we'll put that for next time to look into what can be done for the edge detection and tuning, and if resolution is a factor on this. And if it is, yeah, let's check the literature, do some tests, experiments to see what can we do to work around that issue. But yeah. So thanks if you're watching, and if no one watched this, NDR, you have your first chapter in your logbook. Thanks, guys. So many hours later, quick revisit. So I managed to get D3D shot working. It was a nightmare, but in short, let's see, what did I do? I basically did install the 3D shot, no gets. I guess it will tell me it's already installed. There you go. So I forced it. So the issue is it requires Pillow version, I can't remember, 7.1. The latest is 9. As far as I can tell, it is not having any impact. And the other thing is, what's cool about this library is it supports saving in Pillow format or in NumPy format. And according to the developer, I've not been able to prove this, and I'm getting nowhere close to their performance, but they almost get double the frame rate that you would get otherwise with NumPy. With Pill. It also supports PyTorch. Unfortunately, I could not install PyTorch. I have another conflict in modules, but yeah, whatever. Not entirely convinced, so I want to show you what I did. So yeah, import D3D shot. I have two methods. One is a screenshot method and one is a buffer method. Yeah, so here's the actually screenshot method. So we instantiate the D3D shot object, and we set capture output as NumPy. So then we don't have to convert the result to a NumPy array. And yeah, this wasn't always necessary, but because I have a 2 monitor setup, display 0 is forcing it to be the right monitor. And then we do screenBuffer.screenshot with a region, so it supports the region method. In case of a buffer, we can tell it in the create call NumPy, and we tell it a frame buffer size. So I have no idea if this is megabytes or number of frames. I'm assuming it's number of frames, so I put 20, for example. And And in this case, actually, the region needs to be set when you have to call the capture function and tell it which region. So this is going to feed the buffer. And instead we get the latest frame from the buffer. Now this is going to be interesting because performance is kind of what you'd expect. Okay, so occasionally I get this issue. I don't know. I'm not closing things properly. So I get an error. So sometimes I have to run it twice. Anyway, so in the same method as before, okay, no, what did I mess up in the math? Just playing with the equations a while back, and yeah, what did we break? So the 1000 is only at printing. Do I have 1000 only at printing? Yeah. I don't know what's this. Let's try again. And see some complaints about some process. Okay, divide by 0. I thought so. So it's very bizarre. It's occasionally claiming to have been able to get things done pretty fast. Let's see. It's bizarre. It's bizarre, but okay. I guess what we could do is here add a -1, -3, -7. Well, let's try that. Because, yeah, still says divided by 0. So how can that be? Let's put a 9. And this will only mess up the first loop of the calculation. Period equals 10 time, yes, last time, 10 time. Yes. I don't know. I tell you what, you know what? Let's put a weird number. That's 5. And yeah, I know we shouldn't be replicating code, but okay, there we go. So yeah, this doesn't make sense because yeah, I mean this is claiming to be less than 1 frame a second, right? But we clearly have more than 1 frame a second. So let's see where is what I suspect to be a logical bug. Sanity check. Let's run this one. Yeah, so those are the sort of numbers we expect, right? So what do we have here? We have time period. Yeah, I don't know. No clue, Bob. Let's copy those 3 and let's. So that's absolutely not where I had to paste them. Yeah. Man, this is crazy, totally crazy. I had it running a few minutes ago, so. Okay, there we go. Now we're in the right range. So, which method is this? This is first the buffer method. So we get consistently, or it seems to be consistently higher numbers. We're getting a frame rate of, yeah, what's that? Let's move this down, this up. So we're getting around 16 plus 17. So it dips in the nines sometimes, and that's what is unbearable. So we start the race again. The inconsistency of frame rate makes it difficult to play as a human. So you'll see what I mean. So we're going, and yeah, it's just, you can see the jump, the jerk. It's not a smooth experience, and missing that occasional frame is, let's say, difficult for me. And I think it might be difficult for an AI agent, because I guess it inadvertently will learn. If it's learning a policy, it's assuming the reward that will be achieved in the next time step. And if the next time step is phenomenally different, yeah, I suppose, I mean, it's only two time steps later, so it can hopefully catch the wrong action. But yeah, definitely stuttery. Now, what's interesting is if we go to the capture method, it becomes a smoother playing experience. We don't have stutters, and we get even higher frame rate. So who knows? Seems good. 20s, we're hitting 20. So I suppose it's also inconsistent, but it's at a higher frame rate. So the time step is shrinking effectively. So as you can see, we're getting 15s and all the way to 21 frames per second. And I'm sure if we remove the print screen, eventually it will be faster. I don't know, maybe we could have a look at that now. So, I mean, obviously we won't be able to see the printout, but this magic button, which I don't know why. So, oh, I forgot. Opposite way around. So, this is the buffer method. Yeah, I call them in the opposite order of what I define them as, because I am weird that way. So here it's printing, right? I think this is the non-playable way. Yeah, it's very jerky, that's for sure. Now, Q. Yeah, in some moments we can see the continue flicker just right? Yeah, still laggy, but I don't know. It feels better. It's gonna be difficult to, at least with the code I have so far, it's gonna be difficult to objectively quantify which is better. So yeah, I'm sticking with this. The three reasons. The documentation says it's extremely fast. Not been able to get that, but it's definitely not slower than the other methods, so let's stick with it. Also, the dev is trying to do something similar to myself, so yeah, let's help the community. Second is it outputs NumPy format natively or object type, so that's good. We love NumPy. And third, it seems to have a lot of options, so probably if I play around with it, I'll be able to get more out of it. And yeah, subjectively I'm happy, so I guess that's kind of 3.5 reasons. Thank you.